Welcome to the Module 1, Lesson 1 of our comprehensive course, Hydrogen Fuel Cell and Energy System. I am pleased to guide you through this introductory lesson on hydrogen as an energy carrier. This entire module focuses on the fundamentals of hydrogen and energy system. By the end of this lesson, you will achieve two main objectives. First one, you will understand why hydrogen is called the fuel of the future. Second one, you will learn about the essential physical and chemical properties. This fundamental lesson is designed to take approximately 2 hours and your understanding will be evaluated through a short quiz. Let's begin by understanding why the world is rapidly moving towards the hydrogen-based energy system. Hydrogen is considered the fuel of the future primarily because of the reason is very simple. When we use hydrogen as a fuel, the only byproduct is a pure water. Because it is a carbon-free hydrogen power system play a major role in reducing emission from vehicle, industry and power generation. Furthermore, the hydrogen can be used efficiently in a fuel cell. A fuel cell converts chemical energy directly into the electrical energy without the combustion, and this process is efficient, silent, and completely pollution-free. Countries around the world, including Japan, Germany, India, and South Korea, have announced strongly hydrogen policies, with with India recently introduced a vital concept to grasp is the definition of hydrogen as an energy carrier. Hydrogen is not a primarily fuel like a crude oil or a coal. It is not found freely in a nature in a usable form, meaning we must first produce it using energy from the another source, such as solar power, wind power, or a fossil fuel. Once produced, hydrogen can store the energy and deliver it whenever required, making it similar to a battery in a gaseous form. This capability to store energy, transport energy, and release energy when required make the hydrogen a perfect energy carrier. For example, solar electricity generated during the day can produce hydrogen through a electrolysis. That hydrogen can then be stored and used at a night or transported to another location. So that's why we call hydrogen decouples the place of generation from the place of use. Hydrogen has some extremely unique properties. It is the lightest element in the universe and has the highest energy per kilogram compared to any fossil fuel. This high energy density it is the greatest advantage of hydrogen, around 12 kilowatt hours of energy per kilogram. In contrast, hydrogen contains nearly 33 kilowatt hours per kilogram, close to 3 times more than a petrol. This means hydrogen can store large amount of energy while remaining extremely lightweight. Let's look at the characteristics that make hydrogen both useful and challenging. Physically, hydrogen is a colorless, odorless gas at a standard condition. Its density is extremely low, meaning it rises upward very quickly when leak. Because of this law of density, hydrogen requires compression, typically 350 bar for medium range or 700 bar for a long range to store usable energy from the hydrogen. So next property is a chemical property. Hydrogen's formula is S2 and it is highly reactive. It burns with a pale blue flame and produces only water after combustion. Let's compare hydrogen with other major fuels. Compared to petrol and diesel, hydrogen has almost 3 times more energy per kilogram. And while petrol produces CO2 and pollutants, hydrogen produces only a pure water. For convenience, both petrol and hydrogen refueling times are similar, around 3 to 5 minutes. The primary advantage of hydrogen is a zero tailpipe emission. Compared to CNG, both are gases, but hydrogen is lighter and needs the higher pressure for storage, operating at 350 and 700 bar compared to CNG's 200 to 250 bar. Hydrogen also provides higher energy per kilogram and burn cleaner. The comparison with electric batteries is where hydrogen is benefit for heavy duty application truly stand out. Battery packs store energy chemically but are extremely heavy. To store 30 kilowatt hours, a battery may weigh between 200 to 300 kilogram. Hydrogen is in a contrast, can store the same energy in just 2 to 3 kilogram. This is because of hydrogen fuel cell system lighter than a batteries, which is why hydrogen is preferred in heavy weight application like buses, trucks, defense vehicle and aviation. For a fleet operation, charging time is a critical factor. Hydrogen refueling takes less than 5 to 10 minutes, similar to liquid fuels. EV battery charging, however, can require 1 to 6 hours or even 5 to 7 hours for normal charging, creating costly downtime. Hydrogen also require no recycling step and leave no residue, achieving infinite cycle efficiency. In contrast, lithium-ion batteries contain elements like lithium, cobalt, nickel, and recycling them currently has a efficiency between 40% to 70%. It is important to note that hydrogen is not replacing batteries entirely, but it plays a critical role where battery not suitable, such as for long haul trucks, intercity buses, and mining vehicles that require long range and fast refueling. Role in a net zero transformation. Hydrogen plays a critical role in a global move towards net zero carbon goals. It eliminates CO2 emission in mobility as a fuel cell vehicle emits only water vapor. Second point, it significantly reduces the industrial carbon footprint in a heavy sector like cement, steel, fertilizer, and refineries by replacing fossil fuels. Third point, hydrogen enables the storage of renewable electricity, allowing fluctuating solar and wind energy to be stored and used whenever it needed. Fourth one, it also makes aviation and shipping cleaner, sector that cannot run efficiently on a battery due to several weight limitations. These applications are already underway with hydrogen buses in India, hydrogen train in Germany, and hydrogen-based steel manufacturing taking place in Sweden and Germany. Slide number 10. Since manufacturing hydrogen is necessary, let's look at the four major production pathways. First one, water electrolysis. This is the most sustainable method, splitting water into hydrogen and oxygen using electrical energy. When, when renewable electricity from solar or wind is used, the product is called green hydrogen, which is nearly zero carbon. Second point, natural gas reforming, SMR. This is the most widely used method globally, accounting for 70% production. Methane reacts with a steam to produce hydrogen and carbon dioxide. Since the release CO2 emission, industries are adding carbon capture and storage system. When combined with CCS and produce, the product is called a blue hydrogen. Third one, biomass gasification. This pathway converts agricultural waste, food waste, or municipal waste into gas mixture called syngas, from which hydrogen is separated. This is a valuable. It creates sustainable waste to fuel cycle. Photocatalytic water splitting. This is an advanced research method that aims to use sunlight directly with a special catalyst to break water molecules, mimicking photosynthesis. This technology is still in the laboratory. Hydrogen production is a spectrum of technology evolving rapidly from conventional reforming to smart, renewable, and powered innovation. To summarize this introductory lesson, hydrogen is a carrier of a green energy. It has unique physical and chemical characteristics, being lightest element with the highest energy density per kilogram. Compared to petrol, CNG, and batteries, provides extreme energy density with a zero emission. This makes hydrogen the backbone of green mobility, clean industry, and carbon neutral energy system. This understanding forms the foundation from which we will proceed deeper into fuel cell system, hydrogen manufacturing, storage, vehicle integration, and advanced engineering mechanism in upcoming lesson. Before we conclude, your practical assignment for this lesson is to compare hydrogen versus petrol, diesel versus EV battery in a table format. Thank you for completing module 1, lesson 1. We look forward to seeing you in a next lesson.